So I'm Kyle Maxwell. I'm working on developing a deformable surgery simulation with virtual haptics. In the device here there's motors that will resist your motion and that sort of thing so that you can understand or you can feel what's going on in the simulation. So if you touch against the surface, it's going to put the brakes on and it's going to feel like you're actually touching it, which is what the surgeon would feel as well. What we're modeling here is a extraction task. So say there's a tumor or some or an organ that's malfunctioning that needs to be removed, like a appendix or a gallbladder or something like that. I can use that to interact. If I move over here, I can feel my hand is being stopped. Whereas here we have the surface, and then I can push against it, and you can see how the texture changes and deforms as I interact with it via the device. There's several different tools that the surgeon uses. So we've modeled here, this is similar to, it's supposed to be like a cautery tool. And then there's another tool that you have here is a grabbing tool. So by pressing down on the button here, which is similar to they'd be squeezing some tongs. So I'm going to use the cautery tool to cut away at the mesh a little bit, or cut through the organ. And you can see it kind of makes a dent here. And then we can also, poke around at this dent that we've made. So kind of continue to cut and see what we can find to remove more of the flesh. And then here, this is what we're looking for. So then you can use this grabbing device to come in, feel the surface, and then extract the undesirable object. This allows you to kind of really be inside of the simulation and focus on what you're doing. And the higher resolution allows for more detail as well. And also just this whole project is bringing a lot of different groups together via this wall, and it's a good way to work interactively with different groups of people.